Hello everyone, myself Naveen Kumar. Today we are going to solve one dynamic programming based problem. So before going to solve the problem, let me just give a gist of what is dynamic programming. Actually, dynamic programming is a very powerful technique with which we can solve any very complex problem by breaking it into a simpler recurring subproblem. So the basic thing which we need for dynamic programming is uh, we need to find the overlapping subproblem. That means if we are doing the same thing again and again, we instead of doing that, we just remember it using one data structure or anything. Then we will solve the problem. So it's a basic thing. You can read from here. Similarly, there are two main strategies which we can use in dynamic programming, which is bottom-up approach and another one is top-down strategy. In bottom-up strategy, we use iteration technique. In top-down approach, we use recursion. So actually, in iterative approach, what we do means we identify the subproblem and thereby we solve the largest problem. Here the cache or the memory unit we use is either an array or any multi-dimensional array. Then in top-down approach, it is the recursion approach is called memoization. Here we use hash table, binary search tree, or any dynamic data structure. So this is the general gist. This is the theory part. Now we just going to solve the problem. So the problem statement given is you are climbing a staircase. There are n steps. You can take steps either 1 or 2. Calculate how many distinct ways you can climb the top of the staircase. For example, if you are given a staircase of size n, they are also mentioned either you can take 1 or 2 steps at a time. So if you are having only one step, we can reach there by just one way. If you are having two, we can reach by two ways. Let me show it with the diagram. Yeah, here you can see this is a staircase of size 1. So here you can see you can come here by just one way. But if you have standing in the staircase of size 2, we can, if n equal to 2, there are n 2 steps. We can reach the nth step by either we can, let me think it in reverse direction. If you are in the top staircase, you can come either from before step or the next before step. So this is the way. Similarly, if you are standing in the staircase, you can reach by the previous n minus 1th step or the previous n minus 1th step. So this idea will give you back to a recursion. So if you think of a general recursion case, how you can arrive at this? It's f of n is equal to you can reach either from n minus 1th step or you can reach from n minus 2th step. So this is the way you can reach. So here what is the base case? If the number of staircase is 1, you can reach it by just one step. If the number of staircase is 2, you can reach there by 2 steps. Here actually this problem can be solved by many ways. So I will just discuss what are the approach available. Let me share my screen again. Yeah, I have my code. You can refer here. So actually, first thing we solve using top-down recursion. In top-down recursion, what we do means as we solved here, there are totally two base cases. The first base case is if the number of steps is 1, then we simply return the number n, that is 1. In case of this is the base cases. Similarly, if the number of steps is less than or equal to 0, we simply return 0. So we have no steps. In other cases, the recursive cases, we just need to calculate the sum of the n minus 1th step, how many ways we reach the n minus 1th step, and how many ways we reach the n minus 2 step. We just add sum of this and give this. This is our answer. So here the time complexity, what about time complexity? The time complexity is order exponential time complexity. So if we want to optimize it further, we can use dynamic programming. In dynamic programming, as I said earlier, in top-down approach, we use one dynamic data structure. So here we use vector. So using vector, I'm just solving. For example, instead of recalculating the thing again and again, I am just storing the value in data structure. Whenever I'm calling the recursive case, I'm first seeing whether the it is already calculated or not. If it is not calculated, I am calculating and returning. Otherwise, if it is available, I straight away giving. So it's decreasing the time complexity. So the time complexity becomes simply O of n, but the space complexity we are consuming. So this is one case. So if we are going for bottom up approach, we are going for iteration. So in iteration also, straight away you can go for DP. It's very simple. Here you can observe there is array of 1, you can straight away give 1. Array of 2, you can straight away give 2. Array of 0, you can initialize as 0. Everything is 0. Then you go from the third one to last in nth element. You just simply give the sum, store the sum in array of ith element. So this is a recursive that equation. So then you straight away return the nth element. So this is the bottom up approach using iteration. If you carefully observe, the pattern is nothing but a recursive pattern, which is nothing but a Fibonacci sequence. If you can observe, wait a minute. Yeah. If you can clearly observe, for one step we are having 1, the next step we are having 2. If you are having the third step, which is nothing but n minus 1 and n minus 2, 2 plus 1, which is 3. If it is next 3 plus 2, which is 5, 5 plus 3, which is 8, then 8 plus 5, it is 13. So if you carefully observe, which is nothing but nth Fibonacci number is asked. So if we straight away understand the mathematical analogy, we can very well solve it using even more efficient. As we know, we are familiar with Fibonacci sequence. We can solve it even in O of n space. We just don't need to store everything in an array. Instead of storing in an array, we just need 3 variables. After completing the first 2 things, we just shifting the elements. By thereby we will get the answer. So this is optimized solution. So these are the various approach by which you can try this problem. So I have solved this problem in CodeSignal. So thank you everyone.